Hello everyone, my name is Yağız Baha Demiryürek and I am a mechanical engineering student in Bilkent University, and the video is about my freshman 102 lab project, which is about examining inductance with the change of radius and the number of turns. In this video I will be mainly talking about the aim of the experiment, procedure of it, the equipment list that I've used, and experiment itself, and at the end the conclusion part. So let's begin with the aim of this experiment. My objective in this experiment was to understand the change in the inductance of coils while changing the radius and the number of turns in a solenoid. The area and the number of turns will be changed and examined, and that's why I was able to understand the behavior of the inductance of a coil. As you can see on the screen, there were three main elements that I've used in my experiment, which are a multimeter, a lab wire, and a copper coils with different radius and a number of turns. So let's talk about the procedure. And the experiment itself. The procedure and the experiment begins with the copper wires. The copper wires should be wrapped as cylindrical shells to build the inductor. To search the effect of turn number, wires will be wrapped in shells with three different turns to examine the effect of turns on the inductance. To search radius effect, there will be three inductors with three different radii. However, these inductors have the same number of turns to neglect the effect of turn numbers. The final number of the inductors will be 5. First, the number effect will be examined by measuring it with a multimeter. The values will be put on a chart. Second, the radius effect will be examined by measuring it with a multimeter. The values will be put on a chart to draw a plot, which will be about the radius and inductance. At the end, the conclusion will be written. In the experiment, as mentioned in the procedure, I examined the values of the coil with different numbers of turns, which are 200, 400, and 800. Later, I calculated the inductance with the given formula and found three different values. I put the experiment and the calculated values in a chart to compare and understand the behavior of inductance. Regarding radius, I examined the values of inductance with three different radii, which are 1 cm, 4 cm, and 5 cm. I wanted to overcome the effects of the number of turns, which is why I used three coils with 400 turns. I calculated the values of the coils with the formula and put them on the chart to make a plot, which you can see on the screen. I evaluated the error and draw the baseline. So let's continue with the conclusion. My experiment's main objective was to examine the inductance while changing the radius and the number of turns of the coil. My expectations from the experiment was that the inductance would increase with the bigger radius and the greater number of turns, since the formula shows that with the greater number of turns and bigger area, the inductance will increase. Area is directly correlated with the radius, hence with a bigger radius, the area will get bigger. As expected, the inductance increased with the change in radius and the number of turns. However, the calculated and the examined values were not the same. The reason for that error is measurement mistakes and the difference between real life and the given values. Coils can get damaged because of the usage, or the multimeter might not evaluate the exact value of inductance, since the inductor might not be connected appropriately to multimeter. In the end, I have learned that the change in radius and the number of turns is in a direct correlation with the inductance. Thank you for paying attention and watching my video.